Why did Neanderthals, despite possessing brains larger than ours and surviving in Europe for over 300,000 years, stop moving to follow the migrating summer birds? Why did your heavyset, thick-boned evolutionary cousins give up on long-distance seasonal migration when your scrawny, thin-boned modern human ancestors kept following those avian highways across entire continents? And how did this single decision to stay put reshape the fate of two human species forever? To solve this fascinating evolutionary mystery, we must first dismantle the modern misconception that ancient humans were mindless wanderers who drifted aimlessly across the landscape like autumn leaves in the wind. Movement in the wild is never free. Every step a living creature takes costs precious calories. For hundreds of thousands of years, ancient hominins paid close attention to the sky. Birds are the ultimate seasonal indicators of planet Earth. When wild geese, ducks, and cranes begin their long autumn flights, they are signaling a massive ecological shift. They are fleeing the coming freezing temperatures, the death of plant life, and the sudden disappearance of insect and aquatic food sources for many early human species. Following those feathered seasonal guides was the ultimate strategy for staying alive in a comfortable climate year-round. Yet when archaeologists excavate Neanderthal campsites across the frozen steppes of France, Germany, Russia, and Central Europe, they discover a bizarre, mind-blowing pattern. Neanderthals were not long-distance migratory nomads. They were hyperlocal persistence dwellers. When winter approached and the summer birds flew south, Neanderthals did not pack up their camps and march hundreds of miles across mountain ranges to stay in warm weather. They stayed right in their home valleys. They doubled down on local survival, facing sub-zero blizzards, freezing winds, and extreme seasonal starvation. How do we know this with absolute scientific certainty? The breakthrough evidence comes from the pioneering excavations led by Professor Clive Finlayson, the director of the Gibraltar National Museum. Professor Finlayson spent decades excavating Gorham Cave and Vanguard Cave on the southern tip of the Iberian Peninsula. These coastal limestone caverns represent one of the very last strongholds of Neanderthal civilization on Earth. Inside these caves, Professor Finlayson and his international research team uncovered thousands of fossilized bird bones mixed directly with Neanderthal stone toolkits and campfire hearths. By analyzing microscopic cut marks left on those bird bones by sharp flint blades, Professor Finlayson made a startling discovery. Neanderthals were not just hunting giant megafauna like woolly mammoths and bison. They were actively harvesting a wide variety of bird species, including rock doves, red-billed choughs, alpine swifts, and golden eagles. But when researchers examined the seasonal growth rings in the bird bones and the specific species preserved in the cave sediment, they found something extraordinary. The birds harvested by Neanderthals were not long-distance migratory flocks that passed through for a few days in autumn. They were resident species that lived year-round in the surrounding limestone cliffs and coastal crags. Neanderthals were exploiting a tight, localized ecological perimeter. They were harvesting the exact same local bird populations in January that they harvested in July. They had completely detached their seasonal movements from the long-distance migratory flight paths of summer birds. Why did Neanderthals give up on chasing the summer birds across vast distances? The first major scientific reason comes down to the brutal physics of human metabolic cost and body design. This brings us to the landmark bioenergetic research of Dr. John Speth, a distinguished professor emeritus of anthropology at the University of Michigan. Dr. Speth devoted his career to studying how calorie demands and dietary fat dictated ancient human hunting and mobility choices. When you look at the skeletal structure of a Neanderthal, you are looking at a living biological furnace built for extreme cold resistance. Neanderthals possessed broad, barrel-shaped chests, short, thick limb bones, and immense muscle mass. A typical adult Neanderthal male weighed nearly 200 pounds of dense muscle and heavy bone. To power this massive muscular engine in the freezing European cold, a Neanderthal required a staggering 4,000 to 5,000 calories every single day just to stay alive. Now, consider the mathematical reality of long-distance seasonal migration. If a Neanderthal group decided to follow a flock of summer birds migrating 800 miles from northern France down to southern Spain, they would have to march across treacherous, snow-covered mountain passes, deep river valleys, and dense forests, walking 800 miles carrying heavy wooden spears, stone tools, and young children burns millions of precious calories. For a sapiens hunter with a lightweight, slender body, long stride, and energy-efficient running gait, long-distance walking was relatively cheap in terms of energy expenditure, but for a heavy, hypermuscular Neanderthal, long-distance traveling was an energetic catastrophe. Walking hundreds of miles across rough terrain drained their fat reserves faster than they could hunt to replenish them. Chasing fast-flying summer birds across entire continents was an energetic loss. The math simply did not add up. They burned far more calories chasing the horizon than they would ever gain by staying in warm weather. The second profound reason why Neanderthals stopped following the summer birds lies deep within the neurological architecture of their brains and the size of their social networks. This brings us to the world-famous social brain hypothesis developed by Professor Robin Dunbar at the University of Oxford, alongside comparative brain allocation studies by Dr. Eilund Pierce. Professor Dunbar and Dr. Pierce demonstrated that while Neanderthals had brains that were slightly larger on average than modern humans, their brain space was organized very differently. A huge proportion of the Neanderthal brain was dedicated to processing visual information from their massive eye sockets and managing their heavy physical bodies in the dim, low-light European forests. As a result, Neanderthals had smaller social brain regions, limiting their cognitive capacity to maintain large, complex social networks across vast distances. A typical Neanderthal band consisted of only 10 to 15 closely related individuals, and their total regional network rarely extended beyond 20 or 30 miles. Think about what this social limitation means for long-distance seasonal migration. To follow migrating birds across 800 miles of open wilderness, you cannot simply march through foreign lands whenever you feel like it. You will inevitably cross into territories inhabited by other human groups. If you do not know those groups, if you do not speak their dialect, and if you have no established social alliances with them, stepping onto their hunting grounds means immediate war. To migrate long distances peacefully, a species must possess expansive regional trade networks, shared symbolic tokens, and diplomatic gift exchange customs that allow strangers to welcome each other as allies rather than kill each other as invaders. Sapiens possessed those large social networks. Sapiens bands maintained trade relationships across hundreds of miles, exchanging marine shells, mineral pigments, and fine stone tools. When autumn arrived, a sapiens band could pack up their light tents and follow the migratory birds along well-established seasonal corridors, passing safely through the friendly territories of allied tribes. Neanderthals, trapped by their hyper-local social structure, had no such luxury. Moving 50 miles to the south meant stepping into the territory of a completely unknown, potentially hostile neighboring band. Trapped by social isolation and territorial friction, Neanderthals were forced to stay within their familiar home valleys. They had to master local survival rather than risk death in foreign lands. To see how these two contrasting survival strategies played out on the ground, let us reconstruct a concrete scene from 45,000 years ago during a bitter, freezing October in the foothills of the Pyrenees Mountains in southern France. Imagine you are a 30-year-old Neanderthal hunter sitting near the entrance of a shallow limestone shelter. The autumn air is thick with frost, and the ground is covered in a crunchy layer of ice. You are wearing thick, cured hides wrapped around your wide shoulders. Your broad face is flushed red by the biting cold wind. You look up through the bare branches of the oak trees and spot a massive flock of wild geese flying high overhead. They are moving fast, their white wings catching the fading golden light of the afternoon sun as they slide effortlessly toward the warm valleys of the south. You watch them go, but your eyes do not fill with a desire to follow. You turn your gaze back to the floor of your cave. In your calloused hands, you hold a flat piece of local flint and a bone hammerstone. You strike the flint repeatedly, flaking off sharp, thick scrapers. Instead of packing up your camp to chase the flying geese, you prepare for the local winter harvest. You know every rock, every bush, and every limestone crevice within a 6-mile radius of this cave. You know that in 2 days, when the first heavy blizzard hits, the local wild rock pigeons will gather by the hundreds inside the high, sheltered chimneys of the cave ceiling to escape the freezing wind. You know that herds of mountain ibex will move down from the high peaks into the narrow ravine right below your cave entrance to seek shelter from the snow. You do not need to follow the summer birds to the Mediterranean Sea. You have transformed your local cave into a fortress of survival. You will gather fallen pine nuts, set traps for local cliff birds, ambush the ibex in the narrow valley bottleneck, and crack open their fat, rich marrow bones around a warm hearth fire while the blizzard rages outside. Now, let us walk 50 miles down the river valley and step inside a sapiens camp during the exact same freezing October afternoon. The physical weather is identical, but the scene is completely different. You are a sapiens hunter standing in the middle of a bustling, temporary seasonal camp set up near a river bend. Your group consists of 40 people from 3 interconnected families. You wear light, tailored leather parkas, neatly stitched together with bone needles and sinew thread. As the flock of wild geese flies overhead, your camp springs into motion. No one is sitting down to dig in for a stationary winter inside a cold cave. Your tribe members are packing light, foldable tent poles made of slender birchwood and rolling up light horsehide covers. Your elder leader stands near the river, holding a polished bone necklace given to him 3 summers ago by a neighboring tribe that lives 200 miles to the south near the warm ocean coast. Your tribe knows the seasonal map of the entire continent. You know that by following the river corridor and moving south alongside the flying birds, you will reach a sunny, frost-free valley where wild game remains abundant all winter long. You step onto the well-trodden seasonal trail, moving light, fast, and connected, following the feathered guides in the sky toward a warmer world. This brings us to a profound, counterintuitive scientific twist that changes everything we thought we knew about human evolution. At first glance, the Neanderthal strategy of staying put seems extraordinarily clever and deeply resilient. Why trek hundreds of dangerous miles when you can master your local environment, exploit resident cliff birds, and ride out the winter in a sheltered cave? For nearly 300,000 years, this hyper-local persistence strategy worked brilliantly. Neanderthals survived multiple glacial cycles by becoming master experts of their local microrefugia. However, during the height of the Great Ice Age, planet Earth played a cruel, chaotic trick on the European continent. The climate entered a period of rapid, violent climate oscillations known as Dansgaard-Eschger events. Within a single human lifetime, temperatures would plunge by 10 degrees Celsius, causing localized ecosystems to collapse overnight. Dense forests withered into barren Arctic deserts, and local animal populations vanished without warning. When a localized ecological collapse struck a Neanderthal valley, their decision to stay put transformed into an inescapable evolutionary trap. Because they had abandoned long-distance seasonal migration generations ago, they had no mental maps of distant lands. Because they had no regional trade networks, they had no friendly allies in far-off warm valleys who would welcome them during a crisis. Trapped in their isolated, freezing pockets as local bird and game populations collapsed, small Neanderthal bands suffered from severe starvation, inbreeding, and demographic breakdown. One by one, like small campfires winking out in a vast, dark forest, the isolated Neanderthal populations died out. Your sapiens ancestors, on the other hand, survived precisely because they never stopped moving. Their willingness to follow the seasonal migrations of birds, backed by energy-efficient bodies and wide social networks, gave them ultimate ecological flexibility. When a northern valley froze over and its local resources died, sapiens simply picked up their light gear and walked south along their ancient migratory routes, merging with allied tribes and finding new food sources. The birds were not just a source of food. They were a living navigational system that kept human populations mobile, interconnected, and resilient against environmental disaster. When you mirror this ancient evolutionary story onto your modern life today, the connections are both stunning and deeply revealing. Today, we live in a world defined by an extraordinary tension between our desire for local stability and our deep evolutionary need for global mobility. We build permanent stone houses, install central heating, buy comfortable furniture, and plant deep roots in our local neighborhoods. seeking the same cozy, sheltered security that a Neanderthal sought inside a limestone cave. We love the feeling of belonging to a familiar place, knowing every street corner, and feeling safe in our local routines. Yet, every time autumn arrives and the temperature begins to drop, something strange and ancient stirs deep within your biological wiring. You look up at a flock of wild birds flying south over the highway, and you feel a sudden, quiet wave of wanderlust. You feel an urge to pack a bag, jump in a car, or board a plane to explore distant horizons. That restless urge is not a random distraction or a modern marketing invention. That is the living, unbroken inheritance of your sapiens ancestors, the brave, light-footed wanderers who refused to stay trapped in freezing valleys, who trusted the feathered guides in the sky, and who walked across entire continents to inherit the earth. You step back inside your warm beach house, setting your empty coffee mug on the kitchen counter. You look out the glass window, one last time at the fading autumn sky. The flock of wild geese has disappeared beyond the southern tree line, leaving behind a quiet, vast blue canvas. You pull your fleece sweater a little tighter around your chest and smile softly to yourself. You realize that your modern ability to travel across the globe, to make friends with strangers in distant lands, and to adapt to an ever-changing world is not a modern luxury. It is the continuation of an epic human superpower that began 50,000 years ago when your ancestors looked up at the autumn sky, packed up their light camps, and chose to follow the migrating summer birds into the great unknown.